Hello everybody. Welcome back. So today we're going to talk about substrate neutrality. Can you build a conscious brain made out of anything? And the answer is no. But I'll explain why. It's very non-trivial. I know the typical smart answer is yes, you can build a consciousness with anything. That's what the smart, well-educated people of our time believes, but they're wrong. Actually, there's like key, fundamental problems with that view that are actually not being addressed. But before we go there, the qualia of the day is the beautiful tetrahedron of the phase space of linallyl acetate, phenylethyl alcohol, linalool, and fructone. So, this is what I call making your own scent landscape. So I might apply, fructone here, as part of my sleeve, then a little bit of linallyl acetate over here, and a little bit of linalool over here, and a little bit of phenylethyl alcohol, which is kind of the rose softness over here. And then this is beautiful because it feels like I'm in some kind of garden with a lot of different flowers and plants. And there's a lot of them, many different kinds of them. So there's a lot of linalool producing or fructone producing plants around. And so it gives you this feeling of diversity in the scent. It's not just one thing. In fact, if you apply two perfumes separated, they're not going to mix in the air, at least not in significant quantities, because of the diffusion process. Actually, if you were to visualize it in the air, you would see these single strands and kind of like spinning vortices of one perfume, and then strands and spinning vortices of the other perfume. Sometimes they kind of like somewhat intermingle, but at the microscopic level, they still are pretty pure, actually. So, yeah, there is such a thing as experiencing the whiff of the perfume of somebody who is, 10 meters away at a party. It all has to do with the chaotic air currents. And yeah, for the most part, they don't mix for a while. So this will create a landscape of whiffs, a whiff landscape, if you will. And I think that's entertaining. That's fun. It's hard to kind of like pin down. There's kind of like an event. There's something happening. It's a diverse and rich experience. So I recommend it. And, broadly speaking, I love these four molecules. And they combine well in literally any proportion that you put them. But I do have some favorite proportions. In particular, I love something like 8 times fructone plus 3 times linallyl acetate plus 2 times linalool plus 1 times phenylethyl alcohol, which smells like a very, very beautiful, very sweet, strange flower that doesn't exist. That's kind of a cross between rose and lavender. Okay. So with that out of the way, let me first explain the case for substrate independence or substrate neutrality. Why is it that this is the educated person's view in 2023? And I mean it very seriously. It really is kind of like it separates people who have thought about this and people who haven't. And pretty much everybody who has thought very deeply about this tend to grudgingly or enthusiastically come to the conclusion that, yeah, digital computers or water-based computers can be conscious. Which is what I used to believe, actually, for a long time. But you see, people change. People change. This is a kombucha, by the way, strawberry flavored. Just you want to get a sense of the qualia around here and the landscape of this, the whiff landscape and the strawberry flavor as we chat about substrate independence. Okay, so yeah, there's this thought experiment by David Chalmers called Dancing Qualia. I mean, the idea being that, okay, assume that, let's say, color qualia absolutely requires a particular type of material. I don't know, a particular type of dye in your brain or something, a particular protein. And more so, that you can modularize a brain by substituting one neuron at a time by a functionally identical neuron that essentially looks the same from the outside in terms of inputs to it and outputs to it and the probability that it will fire as a function of the synaptic inputs. Maybe you even replicate local field potentials. I mean, you can replicate a lot of the, low-level functionality of a neuron, let's say with an artificial silicon-based chip, just very, very, very tiny, and powered by glucose or something. But the key point is that this particular implementation does not have, let's say, the protein that is responsible for red qualia, blue qualia, or something like that. So in principle, you could kind of overlay that other type of material right next to the neuron, and then put a switchboard that whenever you flip a switch, all the information and the causality gets routed through the silicon-based neuron. And if you turn it off, then it comes back to the neuron. So the point is that functionally, from the point of view of the neurons around it, all of the connections to that neuron, there's no way to tell that you have a silicon-based neuron inside, because the periphery, the surface area looks exactly the same. So what this is meant to illustrate is that under the assumption that consciousness and, let's say, particular qualia varieties require specific substrates, like specific proteins, then you can arrive at this particular version of epiphenomenalism. Why? Because it means that as you, switch on and off the switch, the color in your visual field will, toggle between being there and not being there. And yet you would not be able to report that fact. You would actually just talk as if the color is there all the time. Okay, so here then, the important philosophical move that is made is, hold on a second, that person who is using the silicon-based neuron is talking about their qualia, talking about their visual qualia as if it was there. And the key philosophical move is to realize that if that is the case, then the reason why he's talking about his color qualia remains the same, because that reason must have some causal effect that influences the process that gives rise to the behavior of talking about qualia. And if you're actually, identifying the neuron as kind of like the functional unit of the brain, you see, and you're successfully replacing it by something functionally equivalent, then any reasoning for talking about your consciousness, talking about your inner experience, your internal representation, will stay put as you do this transition towards silicon. And so all of a sudden you have, hold on a second, consciousness being epiphenomenal. You can replace things, you can get rid of qualia and maintain the same computational properties and the same behavior. And this, because epiphenomenalism is something that we're trying to avoid, because A, we can talk about consciousness. Consciousness clearly was recruited by natural selection for causal purposes, information processing purposes. Yeah, we must conclude, therefore, that consciousness is actually a process. It's actually the process of, transforming the information from the senses into the behavioral output. And along the way, whatever consciousness is must be encoded in that causal structure. And what they would be saying here is that by removing, the biological neuron and putting a silicon neuron in its stead, you have actually maintained the causal structure. And as a consequence, there's just no change to the subjectivity of the system. So this is the state of the discourse. For the most part, people who go against functionalism or people who go against, IIT or computational theories of consciousness or something of the sort, usually do not have a good response to this problem, the dancing qualia problem, absent qualia problem, and how that leads to epiphenomenalism. And that's why the debate ends there, typically. And that's it. All right. It's a wrap. See you next week. Alas, no, there's so much more to say. And there's a key fallacy in the particular reasoning that I provided. And it's a sleight of hand. It's a devious sleight of hand. Oh my God. And you guys fell for it. It's unbelievable. Okay, so let's start out with the following thought experiment. So imagine that, you have a hybrid computational system that has a component that, let's say, uses many quantum coherent qubits in quantum circuits, and it has another component that is using neural networks in a very classical, relatively well understood way, having to do with, synaptic inputs and thresholds of activations and action potentials and all of that. Okay? So we know neural networks are amazing function approximators. If you have enough layers, if you have enough neurons, you can transform any input into any output. And so actually, from a computational perspective within the conceptual framework where computation means transforming an input into an output or having an input-output table that you're preserving, then, sure, neural networks, they look like universal computing systems. Sure, they're universal function approximators. What else do you want? However, there are possible speed-ups that you can get at the hardware level. In computer science, this is called hardware accelerators. A GPU is an example of that, but there's many other ones. You also have like quantum annealers, for example. In principle, I think you can have so many other things. And in the next few decades, I very much think it's going to be the age of accelerators. Not in the sense of, accelerationists, but in the sense of computer hardware accelerators. Just like innovative ways of using fields for computation or using topology for computation, using superconductivity in various ways. I very much anticipate kind of a Cambrian explosion of possible ways of accelerating compute at the hardware level. So in the scenario that I'm positing, you have this kind of ecosystem or like a community of minds that are made up of, a classical, fairly interpretable type neural network system and a quantum component system. Now, the quantum will have all of these finicky properties, right? Like the moment you measure it, it collapses into a definitive state. It follows the superposition principle. It, solves Schrodinger's equation, which is a very weird thing. It's very hard to predict, how that's going to be useful. So really, the way to think about this is no, actually, the quantum component is really inscrutable. And you need this very general neural network to essentially function as its handler. Look, it knows how it works and how it behaves and what are the failure modes. And don't feed it, a qubit while it's in the middle of this computation because everything crashes. And it will have kind of this know-how just by empirically interacting with it a lot, especially if it's like a very core aspect of the whole information processing pipeline. Now imagine a community of these, hybrid computational systems talking to one another. I bet that under certain linguistic constraints, they would actually develop a whole vocabulary to talk about that weird and finicky part inside them that doesn't follow the normal rules of computation, those that, a classical neural network would follow. But it is really potent, it's really powerful, and it is essential for kind of various kinds of deep, fast, ultra-parallel understanding and modeling of the world. Is very effective at, predicting the output of differential equations or differential processes, dynamic systems. Has a lot of kind of beautiful advantages that come to the surface. And there's a reason, why the computational system is using it. Because, it's useful. It actually works as an accelerator in a wide range of contexts. So I would think that in that community, they would have special words to talk about this mysterious part is inside them. And there is a sense in which we can make an analogy to consciousness. That the reason why, we, biological organisms, full of neurons, like 86 billion, billion neurons in our brain with many more glia and so on, all of that could be interfacing with another computational substrate. At QRI, the main thing that we, are working on and speculate on and think about is in terms of fields, even just the electromagnetic field, how can you use it as a hardware accelerator of various kinds? You have the neural networks that are learning to interface let's say, with this secondary and much more holistic, global, and something that acts as a unit and behaves in all kinds of finicky way and has all sorts of failure modes, yes, I think that is consciousness. I think we kind of like push all of the woo and all of the weird things that happen to us to the bucket of, oh yeah, well, that's consciousness doing its consciousness thing and nobody really understands it. It is, I think, yeah, because it is this hardware accelerator component of our conscious intelligent processing system. So that gives you a little bit of a hint of like actually where the answer is of this conundrum of substrate independence. So there you have a case where the actual substrate is in some sense visible, or it matters from the point of view of the community of intelligences that work on a hybrid computational system, because there's reasons to care about it, in particular these computational speedups. So what I want you to kind of like think about here is that really, when I say that consciousness has these computational properties that is being used by natural selection for information processing advantages, I am really talking about the global holistic binding properties of states of consciousness. The fact that on a moment of experience, you can actually simultaneously experience many pieces of information at once, and that this seems to be essential for the kind of information processing that we're used to. We compute and stabilize gestalts that behave as units, and then as units, they interact with each other. These becomes way more, intense and obvious on something like DMT, where exotic gestalts with different properties appear. But the whole phenomena of, these gestalts are essentially working by resonating with each other and computing their valence, essentially how consonance, dissonant, or noise or interactions are. And we're always trying to climb towards the higher consonance. And in the process of doing that, we solve particular problems. An important reframe overall here is that, it is not the case that moving towards higher valence, moving towards feeling better, by necessity always will, solve a computational problem. That's just not the case. I think like in the vast majority of, cases, not in the wild, sampled from real, animals or humans, but I mean in configuration space, like all the possible configurations that you could have of a brain, I think actually in the vast majority of them, the efforts of the conscious part to feel good actually go against the computation that is being performed, because it's a drive towards simplification and synchrony and symmetry and smoothness. Simplicity is kind of like what consciousness wants, in a way. That's one way of talking about it. It's a more complex situation. But in a manner of speaking, what consciousness wants is to become simple. And that is the blissful configuration. High energy, highly symmetrical, simple states of consciousness are the most objectively rewarding. It's kind of like where we would prefer to be if we could. So what happens is that when we are trying to solve a problem, the way to think about it is that you essentially, let's say the classical part, the neural network part of your brain is setting up an environment such that the solution to your problem is a high valence configuration of that environment. And as a consequence, by trying to improve the valence of that scenario, of that context, you will be finding possible solutions to the computational problem at hand. I know this is a little bit of a subtle and tricky thing, but that is kind of like, I think, one of the main things that the non-conscious part of our brain is solving is, how do I present this problem in such a way that by consciousness' natural proclivity to try to find its high valence configurations, it will advance, the goals of that particular computation. In other words, is how do you use valence for solving constraint satisfaction problems? And it's I think it's non-trivial, and we will find it is non-trivial, but also that it is insanely generalizable, meaning that I think like valence computing can underlie a very, very general notion of intelligence. which has all sorts of implications. And it's not going to be just, let's say, a utility maximization system or an optimizer. We're talking about some kind of like satisficer, really, that is like trying to be in an adequate state as opposed to really just kind of like trying to maximize a particular function. So that is significant for AI safety, is significant for alignment. But all of these can only come after you've had the insight of why substrate independence actually matters. So a problem now. Let's kind of like going back to the idea of substrate dependence actually, leading to epiphenomenalism. Like this idea that yes, okay, if the material that you're using in your neuron matters for the qualia that you're having, and if you can substitute it by a silicon neuron and your behavior is the same, does that mean that consciousness is epiphenomenal? Or is it a reductio ad absurdum to property dualism or dual aspect monism? Well, here is the sleight of hand, and the sleight of hand has to do with what are the units in reality where information gets integrated. Because if you do have, something that has non-trivial information integration, let's say many pieces of information simultaneously coming together in order to determine the next step, as in, for example, quantum mechanics, then doing this operation of removing a neuron and substituting it by something else is question begging. I mean, essentially, it is assuming, that reality actually on those scales behave locally in the classical sense that we come to associate with the way a neural network behaves, not realizing that holism could actually be, a problem there. And by that, the obvious example here was, yes, imagine you actually had a quantum core. Your thalamus is actually like a quantum system inherently, and it has like hundreds of thousands of entangled qubits. So here's a fun fact about the thalamus. If you damage it, even very, very slightly, in any way, that usually leads to either coma or death. Whereas if you damage the cortex in pretty much any way you want, yes, you will have like various kinds of cognitive and perceptual disorders, maybe even, attention disorders, but you will continue to be conscious. So there is, I think, like a strong case to be made that, hey, actually the integration of consciousness is happening in the thalamus, and what the cortex is doing is, roughly speaking, painting the walls of your world simulation. But in this case, actually, you wouldn't be able, if this is actually true, you wouldn't be able to take a neuron inside the thalamus and actually replace it by a functional, quote unquote, functional analog. Why? Because the actual proteins inside those neurons actually matter for the entanglement network that is happening. And then, how these neurons evolve over time and their activity is a function of the holistic state, and is not, in that case, something you're going to be able to, substitute in a localized fashion. Actually, it would be an inherently non-local phenomena. From our point of view, big caveat, asterisk, asterisk, asterisk. I know quantum mechanics is local, but it is local in Hilbert space and configuration space, and that actually means it looks very non-local from our perspective, meaning the 3D quasi-Euclidean space we inhabit. Like from that perspective, no, you would not be able to actually just remove a neuron and keep the functionality the same. And, this gets to one of the core issues here, which is how people conceptualize digitality, or I suppose like binary computing at the lowest fundamental level of reality. So here's usually how the argument tends to go, which is like, okay, sure, assume that you need quantum mechanics or, topological fields to explain the behavior of a neural network in the brain. Why can't we just simulate that and maybe at the level of the simulation, the integration would be happening. Well, usually how these arguments will go will be that, well, fundamentally reality is already binary. Reality already at the lowest level is made of tiny Planck length ones and zeros in this massive network of causality. And that is deep reality. And so if that deep reality is capable of simulating, at an emergent level, our brains, and then that at an emergent level creates our consciousness, then clearly, some kind of fundamental non-binary unity at the lowest levels of reality is not necessary, right? Because you can just get away with, some sort of like causal network made of ones and zeros. This is question begging. Actually, this is something that you're assuming. It is open to interpretation. I mean, saying that, reality is made of ones and zeros connected via Planck length interactions, that is an interpretation on physics. Actually, physics, the facts do not imply that. Quite on the contrary. I mean, I'm not going to say that string theory will turn out to be relevant for consciousness, because I don't know. I mean, it seems unlikely given the scales involved. But string theory does have this amazing, insight or property that the building blocks of reality are topological in nature. Meaning, is not point particles as in Feynman diagrams that are interacting or bouncing off each other. Rather, tiny vibrating strings are actually brains, as in like M theory and some other versions of string theory, where like it's not actually just only strings, but it could be other, maybe even higher dimensional vibrating membranes. Well, the way in which particle interactions arise in that world is by the possible topological fusion and fission operations that these particles may have with each other. The topology may simplify, or they may complexify, or for example, you may have like a pinwheel and an anti-pinwheel, or I think like a saddle point, just emerge out of the field. So in this perspective, particles are inherently topological in their nature. And as a consequence, also boundaries in the field of consciousness are inherently causally significant for the building of blocks of reality. Now, with this ontology, well, of course, the problem is like, how do you aggregate strings at, a human scale? Okay, that seems very difficult. But you could imagine some version of M theory, brain theory, where some of the topological features actually do remain capable of holistically encapsulating whole regions or whole sets of particles. I think I could very well imagine, if fundamentally things are actually brains vibrating, that there are some ways in which particles can interact with each other where you actually get a boundary around a whole number of other particles, for example, just by how the topology is unraveling. So, meaning that topological computing could be at the very, very base layer of reality. And in that sense, in that way, the reality would not be made of, points interacting with each other. Is not just a graph, is at the very, very least a hypergraph. Why hypergraph? Because a hypergraph has hyper edges, where you're taking into account many nodes simultaneously and their connections. That, as a data structure, I think is actually capable of at least capturing some of the information integration capacity of consciousness. But I think actually it's going to be a more interesting and subtle mathematical shape, and I think it's going to be inherently topological once we figure it out. That, we will end up having something like understanding your state of consciousness as a series of high-dimensional wormholes that are wrapping around the fields of physics so that you create a topologically closed pocket. And then that can act as a unit, be recruited by natural selection. And you get rid of all of these problems. I will conclude, by kind of like going a little bit deeper into this concept of frame of reference and points of view. Because that is enormously confusing. At QRI we have this particular constraint on a theory of consciousness that is going to be frame invariant, is going to be absolute. We've got to be able to analyze a physical system independently of the frame of reference that we choose and still be able to compute how much consciousness there is, what type of consciousness, what is the valence, what are the causal effects of that consciousness, what are its computational properties. We've got to be able to do all of that independently of how fast we're traveling or from what point of view we're measuring, as long as we're measuring enough information to reconstruct the system. And we consider that an important constraint. Why? Because if something is not frame invariant, it means it doesn't really exist. Like it means for it to exist, you have to look at it from a very specific point of view. Now, some people bite this bullet and they might say, yes, patterns only exist from specific points of view. So what I'm about to say is for them, for people who are okay with the idea of points of view being the integrator of reality. And in that case, like a glider can be conscious, various things that only exist from a specific point of view. You could say, yeah, they're conscious, but only from that point of view. Consciousness is relativistic. Okay, I mean, I think this is nonsensical. It's actually a very, very high grade of nonsense. The sort of high grade nonsense that can really confuse you, and that's one of the problems. No, but I mean, no offense, but yeah, here's the problem though. Here's the problem. Frames of reference don't really exist. So what is a frame of reference? In the many classical derivations of special relativity, you start out with something that you essentially identify as fixed. Like, for example, this cup. You could say, I'm going to assume that the distances between the various elements of this cup remain constant over time. You don't know if that is true, but you assume it. And more so, you decorate this cup with various special points, and each of those special points emit light at regular intervals. And so then actually, yeah, that's your 4-dimensional frame. It is like the 3 axes of space and 1 axis of time, which is determined by this clock, which again, you assume is firing at regular intervals. If you have that, and you have that as an assumption, then yes, you can use that frame of reference to measure everything around you. I mean, you can send waves, kind of like radar or LiDAR, from each of these special points, and you wait for the waves to bounce back. And based on, the relative time that it takes for different waves to bounce back with different textures, you can infer the existence of different things at different distances, both in time and space, away from you, using this frame of reference. Now, here's the thing though, where does the information of this frame of reference get aggregated? Well, first of all, it gets aggregated in your mind. You're looking at this frame of reference and you're making sense of it, and you're, taking note of how the waves bounce back into all of these nodes, and then you're in your mind making sense of that information, or maybe with a computer, doesn't matter. And then the output is produced, and then in your mind you have an image of how that frame of reference is imaging the world around it. Well, the unity is in your mind, is not in the frame of reference. The frame of reference doesn't have objective, causally significant boundaries. Does this make sense? I know it's a weird thing to say, but like, if you actually wanted some sort of like frame of reference that had objective existence, essentially the speed at which the information goes from one point to another should be something like 0, but it's not. The speed of light actually takes time. So even within the frame of reference, those points don't really know to whom they belong until enough time has passed. But then enough time has passed, and then you aggregate information, but then it's not even the point that knows it, right? It's like somebody who's analyzing what is going on with those special points. The information does not get aggregated at the point. The information doesn't get aggregated in the frame of reference itself. The information gets aggregated in your mind. So to think that, oh yes, there is a frame of reference with objective existence, it is projecting the unity of your consciousness out into the world in a place where it does not exist. There are various kind of like spins and further arguments I could make here. One of them uses an infinite regress perspective. Like, well, this half of the reference frame needs to model this other half, and they need to model each other. And then, you repeat that infinitely. You arrive at the strange implication that if you actually wanted to bring the information together, all that information needs to actually collapse into just one point. But one point is by definition zero-dimensional, right? So unless it's a special type of point, such as a point equipped with extra structure, like the Christoffel symbols and, in general relativity, points are equipped with extra structure. They're not just plain points, right? So actually that extra structure is kind of the sleight of hand where the information is getting aggregated and integrated for you. But even then, even within general relativity and the information that gets actually wrapped up inside each point, that is still not enough to encode, let's say, the information about that frame of reference. You still will need something more. There's just not enough bits of information in those points. Okay, so if the frame of reference is not real, where does the unity become real? Where does that get aggregated? Okay, so here's like, the grasping at straws. The bottom of the barrel of the argument would be something like, well, maybe actually the information is not encoded in the frame of reference per se, but in an image that comes from a particular point of view. So you have the frame of reference, and then you have a point of view that sees that frame of reference, and all of the inferences are relative to this pair. And so you thought it was just the frame of reference, but no, actually there's this system, frame of reference and a point of view. And a point of view has two elements. It has an aperture, a tiny point through which, the light rays go through and they flip, the image flips. And then you have some imaging mechanism, a screen. So you have aperture and screen. And the screen is, it's kind of like where you're taking the photograph. That's where the image gets projected and you engrave it or you record it. Okay, so let's work systematically. Where could the information be integrating in this context? Well, you could say it's in the image. Usually that's what we're talking about, right? It's like in the screen is where the information gets aggregated. But the screen doesn't have objective, frame invariant, causally significant boundaries of its own. You have exactly the same problem. A screen does not stand out as a natural unit. The fact that it's rigid, again, doesn't solve the boundary problem there in the same way as like you being you being connected to your muscles doesn't mean that your muscles are part of your consciousness, right? Like rigidity doesn't solve the boundary problem. The fact that the screen kind of has this rigidity doesn't make it a unit, at a fundamental ontological level. Okay, so it's not the screen. So it must be the aperture. Okay, so if it is in the aperture, then let's look at the aperture. Well, there's two possibilities here. Either we're talking about an ideal, kind of imaginary platonic aperture that is just one point. If so, then we have again the problem that one point just does not have enough information. It's a zero-dimensional entity. So the information could have been aggregated there. But if we're talking about a physical aperture, then you will stumble upon the diffraction limit, which is how small does the aperture can get before it actually prevents the passage of wavelengths of light that will form the image without like getting diffracted and distorted or just not going through. And that, that is a frequency specific, which in its own adds a layer of fuzziness because, diffraction, is a function of the frequency and is a soft function. But then worse, there's no objective causally significant frame invariant boundary around the circle of the aperture at the diffraction limit either. So that also doesn't work as a place where information gets aggregated. And at that point, really you should give up. Really you should realize, oh my gosh, that means that you cannot actually bootstrap unitary states of information out of relativity. You can't. And I think like we could prove it even more rigorously. This is enough of a flavor, hopefully, but meaning that, reality, is a reductio ad absurdum. Like this ontology does not support unitary states. There are unitary states, therefore this ontology is wrong, or somewhere along the inference we must have made a mistake. But I think it's the ontology is the one that is problematic, and the way to deproblematize it is to actually posit a different ontology that is grounded in fields as opposed to atoms and forces. And with fields, where you have a field being inherently integrated, and where, let's say, the problem becomes how do you get the boundaries, and we think that topology solves that, then inherently unified or integrated states of the field can exist, which would be all the ways in which you can get a non-trivial topology out of the field. It could be actually, causally significant because the resonant modes of that topology are unique. Its spectrum will be unique. The way it vibrates is completely unique. So if you want that in your universe, if you need those vibrations in your universe, you will require that topology. You will require that substrate. And I think that is, essentially the situation we find ourselves in, where, and this is the bottom line, we need to enrich our conception of computation, where we go from these, I would say, kind of like, naive perspective of computation that maps inputs to outputs, just about replicating a particular lookup table, really, or maybe another less naive, but still quite naive perspective, where like it's about replicating inputs to outputs and the quote unquote causal pathway that led to it. But this will not be able to model or explain or anticipate quantum systems, again, because how do you actually break down the causal structure of a quantum coherent entangled network? What is its causal structure? Like, I don't think actually there's a straightforward answer in terms of networks of ones and zeros operating with each other. I think because you require some degree of irreducibility in the rule set, and as a consequence, we're talking about a very different sort of material. And then, really, what you have to do is enrich your conception of computation, where the inputs, the intermediary states, and the outputs are all allowed to be non-trivial integrated information states. Meaning that this enriched conception of computation will look at, for example, operations that take an entire, let's say, world simulation in a moment, and then copies that, kind of like as an image, literally a Qualia image, copies it, and then mutates it, and maybe re-merges it and edits it, or finds the differences, highlights the curvature of the space, or highlights the color of the space, or inverts the color. And that is the sort of computation I think is very, very exciting. When you think about computation in that super generalized way, you realize that, DMT entities actually are oftentimes doing very non-trivial Qualia computing. Things such as like trying to figure out what you like is computationally non-trivial. In that, how do you present a lot of topologies in front of you? How do you do like some kind of a, state space exploration, or you efficiently search the space when we're talking about a topologically structured space? Very non-trivial. Some DMT entities can do that really effectively in very amazing ways. That is going to be Qualia computing. And it will require a different paradigm, a different way of thinking about it. Again, where the intermediary steps of the computation themselves can be these bound topological pockets. And so, with this enriched conception of computation, we actually would have where a legitimate output of a computation could be a bunch of soap bubbles arranged in a particular way. That could be an output of a computation, because you can take that and then put it into another computer, shine light on it, see how the laser gets deviated or bounces off back and forth into the film of soap. All of that can be computationally non-trivial, right? Like, and you're using this integrated state along the way. Other things could be a topological pocket in the fields of physics, could be a quantum coherent system, could even be a metamaterial. Metamaterial could be, something that is unique to an input or an output or somewhere in between, like aerogel. Aerogel itself, I would consider it a valid output of a computation. And again, if you simulate it, you're actually not going to A, get the full causal structure, and B, it's only going to look real from a specific point of view. And as we talked about, points of view are not real. What are real are, these topological pockets. There's a whole other discussion, which is, okay, so if we are these topological pockets, why does it feel like we're interacting with a 3D, Euclidean world? Like, how do you get a topological pocket to be structured in such a way that being the topological pocket feels like being embedded in a 3D Euclidean space? And that is a very, very interesting question with very, very non-trivial answers, or at least ideas for how to answer it. And we will talk about that in another occasion, because it's a rabbit hole of its own. But yeah, hopefully this enriched your conception of computation, gave you some ideas for, okay, why at QRI we think substrate actually matters, gives you some sense of, okay, why the topology might be significant, and ties together several, hopefully, yeah, we tie together several threads, like, yeah, the slicing problem and epiphenomenalism in Dancing Qualia, and epiphenomenalism in the context of the slicing problem. So with that, thank you so much for tuning in. We'll talk to you again another time, another topic. Infinite bliss, everybody. Take care.